test. So I'm gonna be blunt. I'll be blunt. I'm sorry. Go through the chapter and make sure you're writing down. It's on your note card. You have definitions. Okay. That will help you greatly come the multiple choice portion. Got it? So, and don't come showing up tomorrow going, I didn't write a test today. Don't be like my freshman. He's calling us his freshman. All right, so I'm on page 86, and correct me if I'm wrong. We did problem 1, A, B, and C yesterday. Is that correct? Blessing you. Thank you. So I will tell you that you will see a very similar type of problem like that on the Friday portion of the test, okay? So we did problem number 1. Is everyone good with that, or?
No, we're good.
Good, solid, happy? Okay. If you need it, still need it, if you missed yesterday, the last part of the period on the video is going over it, okay? All right, problem number 2. It says the Denver Recycling Program, oh, we're so green, wants to know the average amount of recycling weight that a household provides per week. A random sample of 200 households produces a mean weight of 14 pounds with a standard deviation of 3 pounds. Construct and interpret a 90% confidence interval. Okay? So we have these 200 people, right? This is our sample. AKA, we'll call it N. We know that they have a mean of 14 pounds, and we have a standard deviation of 3 pounds. Okay? So this is going to be a T sample because we have the standard deviation of the sample. Still with me? And that's going to be a big pivotal part for using the T-table. Okay, so I will make copies of the T-distribution form. Hey there. Don't make it, extra copies of the T-distribution if you misplace it, so you'll have that. So we're going to do this. We have N equals 200. So we're going to go 14, which is our mean, plus or minus. We have to use our T-table for this. Now, what's the problem with using our T-table right now? Our degrees of freedom is 199. What's the problem with the T-table? It only goes to 100, okay? So the T-table at the bottom goes to 100, and then underneath that it goes to infinity. So the best thing to do, what's closer? Is 100 closer, or is infinity closer to 199? 100. So we're going to use the sample for 100, okay? If you notice on there, the difference between them, between 100 and the infinite, you are 2 to 3 decimals in, over that. It's going to start making a difference. So choose the smaller of the two, okay? Now, what if it was like 500,000? Well, I'd say probably go closer to the million one, but 199 is only 99 away from 100, so that would probably be the safe one to go with. So our t-value on that, if we're looking at for 90%, right? So 90% go down to 100. It looks like 1.660. Okay. Now you realize down below you're talking about 0.015 is the difference. So it's not going to be that significant of a difference. If you made a mistake and you went with an infinite, I'm not going to dock you on that. Okay. Times the 3. So this is from the t-table, and we use use the 90% and at the 100 mark. Okay? And it'd be great if you had a calculator because I don't have mine open yet. So you can help me with this. Let's see. And then times our standard deviation divided by our sample size, which is 200. Okay? So would somebody do this math right here? So we're going to have 14 plus or minus something. I don't know what it'll come out to. Hey, I got coffee. Point what?
0.012. Does that sound right?
Maybe 0.012.
I feel like I read it.
Okay, we'll double check. Is it 0.35?
Probably that. I just read it out of. Yeah, I got
0.35? Okay, 0.35 we'll go with. So just because we had two people who verified that.
No, yeah, I think I did it out of.
That's okay. So 1.60 times 3 divided by square root 200 is 0.35. All right, so then construct and interpret a 90% confidence interval. So I'm going to go 13.65 to 14.35. That's our confidence interval. Okay, construct and interpret. So we are 90% confident that if we did this again, that our mean, our average. What happened?
Oh, no, mine.
Oh.
You did put 13, I think.
So we are 90% confident. Oops, go away. 90% confident that we would have an average within our confidence intervals. Basically, that would be fine to something like that to say. Okay.
What will we say? So
We are 90% confident that we would have an average within our confidence interval if we started recollecting more and more data. Okay, seem okay? So, friends, remember, you can use however many note cards you want. So please note that, definitions throughout the chapter definitely have. Symbols, like X bars mean, where do they go with? So make sure you have that information. Before I get to the next problem, so just a few that you want to know. X bar, that's a mean. Just so when you see X bar, you'll know that it refers to mean. I'd say maybe squeeze your definitions onto, one note card. Don't have them like, throughout. Just so you know, that's the one you go to. Standard deviation. This is also a standard deviation. P would be the percent or the proportion. N is the sample size. Okay, so definitely things to look at. And then this would be good to know as well. So if you had a confidence interval, you have the point estimate. Plus or minus is just plus or minus. The critical value times the standard error. And this portion right here, not including the plus minus, is the margin of error. So that would be a good start to start having on some of your definitions, okay?
So can you explain when you would use the z-score and when you would use the t-score?
So T has to do with when you're dealing with the sample standard deviation,
Okay.
but a T also takes place when you have a lot of time. So that's one thing to check. Do I have the sample standard deviation given, T-score? It also takes place when you have less than 30 for the most part. So if you compared the T distribution table to the Z distribution table, and I know I didn't give you the Z distribution, but a Z distribution would look very similar. As soon as you got to the number 30, the numbers are identical.
Okay, so you mean the number 30 for the sample size?
Yeah.
That's the
The-
z-score.
Yeah,
So just if you decide between those.
yeah. So here, let's write that down
I
though.
don't know which one, yeah.
Okay, so T table, and then I'm going to say Z table, but know that we don't have a Z table. I'm not, I could print one up, but your calculator will do the same thing. This is the inverse norm on the calculator. Okay, so the T table versus the Z table. So you use the T table when you have the standard deviation of a sample. And I'm going to say this, and/or a value less than 30. Okay? Does that make sense? So when I say and or, they might not give you they might give you a standard deviation, which you can't necessarily tell if it's from the sample or not. So if those are both true, definitely T-table. If I have a standard deviation that's from the sample, T-table. If I have a n value that's less than 30, T-table. Okay? Yeah.
Are we gonna do the ACT test one more?
Yeah, I will. Degrees of freedom is always n minus 1. So the sample size, subtract 1. Okay? So those are really good definitions to have. Now, so I got to tell you, I'm pretty motivated that we are the ones that are doing, we spent the most time on this chapter. I will say that Mrs. Quayle didn't have the best, but she also is like 3 or 4 days ahead of us. Mr. Anderson is a couple days ahead of us. So I feel pretty good because I know that there's some things that I just want to highlight, and we're all kind of doing the same thing. So if you all do better, it either means I'm an easy grader or you're smarter. So I think it's because you're smarter.
You should say that and then do the other thing,
Be an easy grader and you're smarter.
Yeah, exactly.
So Chris, what's your average on the test? 98%. Oh my gosh, I'm that good. My kids are that good too. Plus, I'm an easy grader. All right. So problem number 3 on page 86. We doing okay on time? What time are we out of here? 9? Okay, we're good. The ACT has a known standard deviation among all test takers of 6. Now, there's something they forgot to put on this one. Notice the next sentence says, a random sample of Wyoming test takers produces an average of 20.5. Okay? So this isn't there, but it should have said that we were going to do a random sample of 100 Wyoming test takers, okay? So that was a misprint. So if you look at the board going, where's that 100 coming from? It's because we're adding it. So that second sentence should say a random sample of 100 Wyoming test takers. Okay? So we forgot to put the 100 in. Can't do it if you don't have the 100. Produces an average score of 20.5. Construct and interpret a 99% confidence interval to attempt to capture the Wyoming ACT score. So first thing I'm going to do, I have 20.5, which is our mean. Agreed? Plus or minus the inverse norm.
So for this one, you would use the z-score?
Yeah. Using the z-score for two reasons. Sample is 100, because we're adding that.
Yeah.
And we are doing the standard deviation of a known standard deviation of the entire population. It's not the sample of it.
Standard deviation of sample.
Yeah.
So when you use T, it's the sample.
So if it said we randomly selected 100 Wyoming students and found their standard deviation was this, then we're taking it from the sample.
Which is why we did the T score on number 2 about the.
Because our sample was the 200 households,
Yeah.
14 pounds with standard deviation of 3.
And that was the standard sample.
That was the sample standard deviation. So that says Z, or says T.
T.
This said the overall standard deviation
Okay.
is the entire population of years and years and years of the ACT. This is what they have found. So inverse norm. Now, they want a 99% confidence interval. So what do we plug in there? 0.995. Why is it 0.995? You're absolutely right, but why is it 0.995? Yeah, so this is the halfway to 100. That's kind of the idea. And then we have times 6. That's our standard deviation of the population. Standard deviation of the population. Okay, over the square root, the 100 was the n. Okay, so I'm going to go 20.5 plus or minus. Will someone do this math here? I'll make this math easier. 6 over square root 100 is 6 over 10, which is 0.06. So 0.06 times the inverse norm of 0.995. 1.5? Do I have a second on that verification? Sounds pretty good, right? So then our confidence interval, construct and interpret, okay? So our confidence interval is going to be 20.5 minus 1.5, which is 19, and 20.5 plus 1.5, which is 22. Okay.
So did you do 6 divided by 100 or did you do 6 divided by 10?
Oh, it should have been 6 divided by 10, sorry. So that should have been 0.6.
Is that right?
Is it still right? Okay. Oh, I see. I said you guys are the brightest, so that's why. Okay, so from 19 to 22. Okay, so let's interpret this. We are 99% confident that that if we select another sample, and you could go as much as you want from Wyoming, ACT test takers, you can put all that, but it's not necessary, would produce, a mean or an average in our confidence interval. Okay. Okay, so all 3 of those problems are probably really good problems to have in a place that you're going to use them. Okay, and I think the most important thing is recognizing when you use the Z versus the T. Have that highlighted somewhere where you know you're going to go to it.
So why didn't we use the T on like 3?
Why didn't I use the T on number 3? Okay, 2 reasons. We had the standard deviation of the entire population. That means no T. And our sample was the 100. It wasn't less than 30. So both those reasons worked very well for our testing. May I move on? Okay, and this is the last of it. These are relatively quicker. Okay, so number 4, they give us this. Okay, so things that we know. This is the standard deviation. Oh, DD, no, SD, standard deviation of a population. Okay, not of the sample. This is our sample. Okay. This was gotten because this was halfway to 100. Okay, so what would we be plugging in there? What would have been given originally if our inverse norm was 0.90? What number is, so 90 is 10 away from 100, right? But in order to get that, I had to have some number that was halfway to 100. So what number would that have been as far as the confidence level? It would be 80. Good. Okay, so it would be 80. Okay, so 80 is our confidence level. Okay. Our margin of error is that whole thing. So you could work it out, but there's no reason to.
Well, it asks for it.
Oh, does it ask for it?
Yeah.
Oh, what does it come out to? 0.85. So this whole thing worked out is this, so 0.85. So you did, okay. Margin of error. Okay, and then our critical point, let's see, what was our critical value? Oh, our critical value would have been gotten to be the inverse norm of 0.90. And I don't know what it is. I didn't work it out. And then our point estimate.
1.28.
This comes to 1.28? Okay. Sounds about right. Hi.
Can you specify it?
Yep. I'm not going to sign off for. I'm not going to sign up for this because I know that you're going to have it completed.
Yeah. That's what I told her, and she was like, because she said that she was gonna put it for both of them, and I was like, wait, but I'm doing the thing where you're gonna.
Yeah. I'm going to put a little asterisk that working with me to complete semester 1 of Algebra 1 CS. Is that okay?
Yeah.
And have them email me if they're like, I don't know. So
Okay.
have them email me. Happy to do it. So our point estimate is what? Is the 50. Yeah, that's our point estimate. Another good problem. It has a lot of information there to know. So I think that's pretty good. And then explain the change. The change is made with the width of the confidence interval. Okay. All right. So number 5A. When the confidence level is increased, the interval is wider. So I might maybe on your note card put all of number 5. That way you can refer to it. Okay? Oops, go away. Letter B. The sample size n is increased. The interval is smaller. And then letter C, when the point estimate is increased, it has no effect. Okay? Meaning it doesn't make it might change, it changes the mean a little bit, but it doesn't change the width of anything. Okay, so friends, with all of that information, I think you have, so I'm going to put it on you. Make sure you go through this chapter. You have the whole chapter. Go through the chapter. Make sure you have all the definitions. I'd put any equation you see in there and maybe label on each of the things, because it'll tell you, like in the directions, hey, this is this. So then you know, okay, this is the equation when this happens. Okay? I will have extra t-tables for you, and I'll probably have a couple of other added notes I'll have up on the board, just in case you might need something like that. Okay?
So we're not doing part 2 of the review?
No. You should be fine. I took a good look at the test. I think that we've covered a good amount, as long as you all figure out, let me get some definitions down. Use however many note cards you want. That's what you got. Okay?